Every smartphone, every AI model, every modern fighter jet, every supercomputer, every advanced chip on earth exists because of one machine. A machine so unbelievably complex that only one company in the world knows how to build it. Not the United States, not China, not Google, not Apple. Just one company, and each machine costs around $350 million. It contains more than 1 lakh precision engineered parts. It is assembled over many months. It pushes engineering to the edge of what physics allows. Without it, the AI revolution would slow dramatically. The newest smartphones would not exist, the world's fastest computer could not be manufactured. So how did one machine become one of the most important pieces of technology on earth? This is the story of the most valuable machine you have probably never heard of. Every day, billions of people unlock their phone without thinking about the incredible technology hidden inside. A tiny chip powers your messages. Another chip connects you to the internet. Another processes photos in milliseconds. Millions of these advanced chips are produced every year. Yet almost all of them share one surprising dependency. Before they ever reach a phone, laptop, or AI server, they must pass through a machine that almost nobody sees. Most people assume the world's biggest technology companies make everything themselves. But even companies like Apple, NVIDIA, AMD, and many other depends on a global manufacturing chain. Designing a powerful chip is only the beginning. Building one is an entirely different challenge. Modern chips contain billions of transistors packed into an area no larger than your fingernail. Creating those microscopic patterns requires astonishing precision. The tools used to manufacture them are not ordinary factory machines. They are among the most advanced machines humanity has ever built. And remarkably, only one company manufactures the flagship machine capable of producing today's most advanced chip. That company is ASML, based in the Netherlands. At first glance, it does not look extraordinary. It's not a rocket, it's not a particle accelerator. It does not fly, it does not drive. Instead, it quietly sits inside some of the world's most advanced semiconductor factories. But appearances are deceptive. This machine uses extreme ultraviolet light, often called EUV, to project incredibly tiny circuit patterns into silicon wafers. Those patterns eventually become the processors that power modern electronics. Generating and controlling this light is extraordinarily difficult. The system requires an ultra-clean environment where every microscopic contamination can affect the production. Some of its mirrors are manufactured to astonishing precision, so smooth that their imperfections are measured at the atomic scale. Inside the machine, thousands of engineering systems work together with remarkable accuracy. Even a tiny error can reduce manufacturing quality. This is not just another industrial tool. It is the result of decades of research, collaboration, and engineering across many specialized suppliers. That complexity is one reason so few organizations on earth could even attempt to build something similar. And that's where the real mystery begins. If this machine is so important, why is there effectively only one company making the most advanced version? And why haven't the world's largest technology companies simply built their own? The answer involves decades of investment, global supply chains, extraordinary technical barriers, and one of the greatest engineering stories of the modern era. In the next chapter, we will uncover how one company achieved a position that many believed was impossible, and why governments around the world now pay close attention to every machine it ships. Imagine you wake up tomorrow with unlimited money, $100 billion, the world's smartest engineers, the best AI, the most advanced factories. Could you build this machine? Most people would probably say yes, but the answer is probably no. Because money was never the biggest challenge, but the time was. The story begins decades ago. As computers become faster every year, engineers faced a terrifying problem. The tiny transistors inside the computer chips could not keep shrinking forever. To make chips more powerful, manufacturers needed to print unimaginable small patterns into a silicon, smaller than bacteria, smaller than many wavelengths of visible light. It sounded impossible, yet one company decided to solve it anyway. Years after years, while many competitors gave up, they keep investing billions into one dream, a machine that could manufacture the next generation of chips. Many experts doubted it would ever work. Some believed the technologies would remain trapped inside research laboratories forever. But after decades of failure, experiments, and engineer breakthroughs, that impossible machine finally has become reality. Today, those same companies that has once competed often depend on it. So, what actually makes this machine worth hundreds of millions of dollars? The answer is not one breakthrough, it's thousands. Inside the machine, an extraordinary chain of technology must work together with incredible precision. The light source, the optic, the wafer stage, the control system, the software. Every part depends on the other. If one critical system falls out of alignment, the manufacturing process can fail. That's why building one isn't like assembling a normal factory machine. It's more like conducting an orchestra where every instrument must stay perfectly synchronized. Each system pushes the limit of modern engineering. Every new generation of chips demand even tighter precision. Engineers spend years refining components that most people will never see. The result? A machine capable of helping manufacturers create the advanced processors found in today's flagship phones, powerful graphics card, AI accelerators, and high-performance computing systems. That's why these machines are so valuable, not because they are made of rare metals, not because they are covered in gold, but because they make technologies possible that would otherwise be far harder to manufacture. But when demand for faster AI, smartphones, and more powerful computer increases, so does the importance of the machine that helps create their chips. But there is one question that makes the story even more incredible. After all, the world's biggest technology firms have enormous resources. So what is stopping them? The answer isn't just engineering. It's a story involving decades of expertise, highly specialized suppliers, international cooperation, and technological barriers that could not be overcome overnight. And that is where this documentary takes an unexpected turn. Today, this isn't just a machine. It has become a symbol of technological power. Every country wants faster computers, smarter AI, more powerful military technology, and stronger economics. But none of them is possible without advanced semiconductor manufacturing. That's why governments around the world pay close attention to these machines. Because whoever builds the most advanced chips gain an enormous technological advantage. Artificial intelligence, quantum computing, medical research, space exploration, self-driving cars. Every major technological revolution depends on increasingly capable computer chips. And those chips depends on extraordinarily advanced manufacturing. This is no longer just a business story. It is a race for the future. Countries invest billions into semiconductor research. Factories are expanding, engineers are in global demand. Governments are supporting new manufacturing capacities because everyone understands one simple truth. The next decade wouldn't be defined only by oil or gold or even data. It will also be shaped by who can manufacture the world's most advanced chip. Most people will never see this machine. They will never stand inside the clean rooms where it operates. They will never watch engineers calibrate its systems. Yet almost everyone benefits from what it helps make. Every video you stream, every online payment, every AI assistant, every navigation app, every scientific discovery powered by modern computing, they all rely directly or indirectly on the ability to manufacture increasingly advanced semiconductor chips. This machine doesn't make headlines every day. It doesn't launch into space. It doesn't appear in blockbuster movies. It quietly works behind closed doors, helping create the tiny processes that powers the modern world. Perhaps that's what makes it so fascinating. Some of history's most important inventions are also among the least visible. When people think about the future, they imagine robots, artificial intelligence, quantum computers, or mission to Mars. But the future doesn't begin with those technologies. It begins with the tools that make them possible. Hidden inside a highly controlled factory, thousands of precision components, working together to build something smaller than the eye can see. One machine, decades of engineering, a technology that quietly helped shape the modern world. And perhaps the most extraordinary part of the story is that almost nobody knew it was there. If you enjoyed uncovering the hidden technology that powers our world, subscribe for more documentaries exploring the invisible system behind the modern civilization. Or sometimes the most important stories are ones happening completely out of sight.